Edwards Air Force Base, California, has been the scene of most of the XB-70A's flight test activity. But it's only the starting point. Flights were made over a 350,000 square mile test range. It was on this range that flights 1 through 4 pushed steadily up in speed and altitude. At the start of the year, supersonic test time totaled 55 minutes, with total time aloft at 5 hours and 2 minutes. But this was history. Flight 5 was the first one of 1965 and marked the start of Phase 2 testing. The plane had just completed extensive proof loading of all movable surfaces in preparation for the high-speed, high-altitude flights ahead.
Sir, is the runway clear now? 001, roger, the runway is clear. Wind calm, clear for takeoff. Yeah, on at 358. 3, 2, 1, brake release.
Most of the functional operations are out of the way, but there remains one more major step, folding the wingtips to 65 degrees.
And I'm going up on 1.4. Can we have the wingtips down 65 now? Now let's take the time history of that. Roger, data on at 1263, and tips coming down.
They've been partway down 25 degrees, but this is the first time for flight in the full down position.
Counter 12890. Right. The wingtips go down, all right? They're coming down. That's it. Tips look like they're down 65, okay. Hey, thank you.
With the plane now shaped for high-speed flight, throttles were advanced, and the Mach meter moved up to 1.6, a new high. The sixth mission rolled down the runway at the heaviest takeoff weight to date. Al White was at the controls, but he looked over at a new co-pilot. Colonel Fitzhugh Fulton was flying his first mission. Data was taken on the normal climb-out, but a drop in hydraulic pressure cut the flight short. Landing gear was lowered and a heading taken back to Edwards. The landing was on the lake bed as a precautionary measure and was without incident. At 385,800 pounds, this was the heaviest landing weight to date. Flight 7, a significant step up. More fuel was aboard, building takeoff weight to 492,000 pounds, a record liftoff weight for Air Force aircraft. Another B-70 record broken was time at supersonic speed. Exactly 1 hour was spent over Mach 1.
How you doing, Chase 2?
I can stay with you for probably about another 10 minutes.
Roger.
Moving the tips down is now becoming a routine procedure, and they are lowered to 65 degrees for flight speeds in excess of Mach 1.4. As speed builds up, chase planes start falling behind. They can only stay with the flight for short periods. The Mach meter pushed up to 1.85 times the speed of sound, and the altimeter registered 50,000 feet, 2 new highs in performance. Speed and altitude are gross measures of achievement, but they're only 2 of hundreds of data points recorded. Data recording at its simplest is the telemetered information, a continuous recording of 36 channels, the ones monitored during flight. The full record comes back after the flight. First, flight recorders put 100 channels of continuous data on tape. A few hours after touchdown, the story of flight streams out in a steady graphic record. But these methods just scratch the surface of a sea of information. The bulk of information comes back in digital form on magnetic tape. 90 million separate individual measurements are brought back on 2 reels. Cramming millions of readings on a 1-inch wide strip takes a digital system. Looking at one slice, one measurement, 13 tracks write down the data. 2 hold timing information, and 1 identifies the source. A 30-inch strip records 20,000 complete measurements. So much data that machines must handle it. Nearly 800 separate sources throughout the plane are questioned regularly. The morning following flight, the first look information is rolling out. 75 vital channels are selected from the 800, and the whole flight stretches out on 200 feet of paper. The first screening is for any items that could be critical and affect safety on the next flight. Then a selection is made, each specialist choosing wide bands of data. Some groups can use tabulated information directly, and high-speed printers turn out reams. Other groups prefer plots of a few functions against time, and yards of this material are supplied. Still another method transfers the facts on 1/2-inch tape for additional processing. Large computers are programmed to correct, combine, yield even more knowledge. The second plane of the series is being built, and early in March, the main landing gear was sliding into position. This is the same rugged H-11 steel strut used on the first plane. The only real difference here is the time and ease of installation. With the experience gained, most jobs take only half as long or less. With the landing gear installed, the plane came off the jacks, resting on its tires for the first time. This operation marked structural completion. Only final installations and operations remained. The bleed air duct installation was major. Its 83-foot length carries warm air forward from the engines to the air conditioning system. Once it was in, another familiar scene was J-93s sliding into their bays. As engines, they may look ordinary, but they're not. One of the first designed to handle 600 degrees inlet air, they are research tools too. Flight and ground runs have already amassed over 1,000 hours engine operating time, and engine performance has been excellent. Their thrust has been pushing the XB-70 ever faster and higher. With flights 5, 6, and 7 added, supersonic time made a sizable increase. Total time now close to 9 hours. The next steps up were to Mach 2, and Flight 8 hit 2.14 and 56,000. 9 turned back with hydraulic trouble, but 10 pushed speed up to 2.30. Both Flight 8 and 10 shared a major accomplishment. Both sustained flight above Mach 2 to a total of 90 minutes. Twice the speed of sound is critical for the propulsion system. At this speed, the main shock wave must enter the inlet and be controlled if speed is to be increased above Mach 2. Taking a look at inlet duct principles, in low-speed operation with the throat open and bypass doors closed, the inlet operates as in any subsonic aircraft. At Mach 1, shock waves form ahead of the inlet. From Mach 1 to Mach 2, the inlet operates as an external compression inlet. At Mach 2, the bypass doors open and the normal shock is drawn into the throat. With a normal shock at the throat, a whole pattern of lesser shocks form to gradually slow the air and compress it. The inlet is started. The most efficient operation is with the main shock near the narrowest point of the throat. Its position is regulated by bypass door movement. When the door opens, the shock moves aft. As it closes, the shock moves forward. As the speed goes from Mach 2 to Mach 3, the throat squeezes down automatically to maintain high efficiency. At design speed, air will enter at the inlet 2,000 miles an hour and be slowed to about 200 miles an hour at the face of the engine while being compressed 31 times. Both flights 8 and 10 showed the inlet would start and operate as predicted. More important, it was deliberately unstarted. The shock wave forced out, then restarted. These successful tests cleared the way for a steady, step-by-step approach to design speed 2,000 miles an hour. Of course, flights may have one main goal, but at the average hour-and-a-half test time, many surveys are made. Stability and control, flutter, system operation are a few among many important areas of investigation. Even drag chute operation and stopping distance are added to the store of knowledge. High-speed flight started to take on a pattern. The XB-70 passes over 4 or 5 states in its tests. Building up to 1,400 miles an hour, a typical circuit takes it north 400 miles. It makes a swing around Salt Lake, and then back to Edwards in 2 straight legs. When Flight 11 reappeared, it had been to 64,200 feet, and it reached Mach 2.45. A large amount of valuable data had been obtained. 57 minutes of it were gathered at speeds over Mach 2. Flight number 12 started as another step up in performance to check the inlet, take flutter readings, investigate stability and control at Mach 2.65 at 65,000 feet. It soon disappeared from sight, heading up the test range, becoming only a dot on radar. Climb was slower than usual due to clear air turbulence and high temperatures. But after a number of tests,
I'm at 65,000, still in the turn. That's 254 now.
and shortly thereafter, the first intimation of trouble.
Number 5 engine vibration is running kind of high. Better pull it back to military.
And a half minute later,
Number 6 engine's going over 10. Give me a heading home.
unknown to either pilots or flight controllers, a piece of structure had carried away the extreme leading edge of the wing. Pieces entered the right-hand inlet duct, damaging the panel face sheets, cutting down to honeycomb. Heavier shapes remained intact, one embedded in the engine divider structure. Most of the debris passed through the engines, causing considerable damage to the compressors. Number 5 was the first affected, but eventually all 3 engines on the right side showed the effects of damage, and number 4 and 6 were shut down. After 10 tension-filled, anxious minutes, the XB-70 was picked up on an approach to the lake bed. Coming back in on 4 engines, the crew had used just about every emergency procedure in the book. Flight 12 was an unplanned test of utmost severity. Its safe return was an outstanding tribute to the competence and coolness of the crew, and to the ability of the plane to withstand conditions and forces that were totally unforeseen. The reason for the difficulty was immediately obvious, and a close look at the data confirmed the sequence of events. The plane headed for the hangar for repairs and engine changes. In another hangar at Palmdale, the second airplane is in the final phase of manufacturing operations. Folding the tips to increase high-speed stability once was looked on as an unusual solution. Now it's proven. So through experience, an unusual design feature becomes accepted, practical. The pace of final operations was steadily moving towards completion of the airframe. Rollout was only a few days in the future as the landing gear swung back and into the wells. This operation had been flight-proven, and the fitting and adjusting filled the last few hours of manufacturing. As the gear was swinging, speeches were already being written.
He didn't mention, though, that it also has been the heaviest airplane in the world to ever take to the air. It has also been the heaviest airplane that has ever landed on one occasion. It is today the fastest big airplane that's flying in the world today. But in less than 2 decades, aviation has progressed forward now to the point where an airplane like the B-70 is flying now at almost Mach 3. As the sister ship to the number 1 that is flying at Edwards rolls out this morning to take its place along beside number 1, I want to congratulate all of you people, North American, the various subcontractors, those who've had a hand in making this day possible. You have every right to be proud.
Rollout day was also family day, and a crowd of 6,500 turned out for the unveiling. With the ceremony over, everyone moved in for close inspection. The plane they saw was not outwardly different, but there have been many subtle changes. Starting at the nose, there is extra instrumentation for gust research. The cockpit has only minor changes, but there's more fuel in the fuselage, approximately 5,000 gallons. This will mean more range, more endurance. The inlets will be fully automatic in their operation. The co-pilot need only monitor their performance. The major difference is in the wing. It has a 5-degree dihedral. The top of the wing shows even more instrumentation. Pressure probes to sample the air along the wing surface. Over 200 additional channels of instrumentation are available on this second plane. Even the pilot staff was taking another look. Colonel Fulton made 3 trips as co-pilot. He was aboard on the 6th, 7th, and 12th flights. Colonel Joe Cotton, the Air Force project pilot, has put in over 6 hours of flight time. Van Shepard, a North American pilot, tells how the brakes worked on his 2 flights in the XB-70. Al White, chief test pilot, has flown the left seat in all missions. These are the men who have proven the B-70 design in many flight situations. They'll soon have 2 planes ready for flight. May 29th ended the manufacturing era, and this second plane of the series is the last to be produced. It was completed in just 19 months, less than half the time it took to build the first model. The experience and know-how gained provide substantial contribution to the technology of supersonic airframe manufacture. Moving back to Edwards, flights 11 and 12 added more research time. Now nearly half the time aloft has been spent at supersonic speeds. The middle of June saw Air Force 001 taxiing out with 3 new engines, duct repairs made, and a new welded stainless steel apex on the wing. Its testing was interrupted on the last mission. This time it is scheduled again to go to Mach 2.6, checking stability and control and inlet operation. Much has been said about speed, but this and the previous 2 flights have reached altitudes of approximately 65,000 feet. There are few planes that can operate here. The XB-70 spent 22 minutes at this extreme altitude. Just outside the glass, the pressure is only 0.8 of a pound per square inch. The air is thin and cold, about 60 degrees below zero. Never has a plane this size and weight entered this area. As speed has built up, so has peak temperature. It reached 429 degrees Fahrenheit on this mission. Flight 13 was the last one of the reporting period. It was up for just over an hour and a half. 1 hour and 15 minutes were at supersonic speed. The plane has logged 17 hours and 43 minutes total. Of this, about half the time has been over Mach 1, 8 hours and 32 minutes to be exact. Soon it will be joined by the second plane, and both will be making significant, vital contributions to the store of knowledge on supersonic flight at extreme altitudes.